Hello everyone, in this video we're going to learn how to solve this AB calculus challenge. Alright, find the integral from 0 to pi over 2 of 1 over cosine x plus a dx where a is a constant greater than 1. Alright, so here's the trick. Whenever you see cosine x or sine x or tangent x, alright, think about the way address. Substitution. Let t equals tangent s over 2. Now we need to change the bounds. Alright, the old bounds s equals 0 pi over 2. The new bounds t equals s equals 0, substitute over here, tangent 0 equals 0. S equals pi over 2, substitute over here, tangent pi over 4 equals 1. Now from this one, we're going to take derivatives both sides. So dt equals 1 over cosine square s over 2 times 1 over 2 dx. Next, because 1 over cosine square s over 2 is going to be 1 plus tangent square s over 2. Now I'm going to bring 1/2 to the front, and then it's going to be dx. Now, because t equals tangent s over 2, so I substitute over here. So this guy becomes dt equals 1/2 parenthesis 1 plus t square dx. Now I need to calculate dx in terms of t. So it's going to be dx equals 2 dt divided by 1 plus t squared. Alright, so I leave over there. Now, next one. I need to find sine s in terms of t. So sine s, alright, equal to sine s over 2 times cosine s over 2. Now I'm going to multiply the top and bottom by cosine s over 2. It turns out to be 2 sine s over 2 divided by cosine s over 2 times cosine square s over 2. Now this guy is going to be equals to tangent s over 2. Now cosine square s over 2 is going to be 1 over 1 plus tangent square s over 2. Now I substitute t for tangent s over 2. So it turns out to be 2t over 1 plus t squared. Now next one, cosine s equals 1 minus 2 sine square s over 2. Now I'm going to multiply the top and bottom of this one by cosine square s over 2. So it turns out to be 1 minus 2 sine square s over 2 divided by cosine square s over 2. And then times cosine square s over 2. Now we're going to simplify. sine square x over 2 divided by cosine square x over 2. It could be tangent square x over 2. So it turns out to be 1 minus 2 tangent square x over 2 divided by cosine square x over 2. It could be 1 over 1 plus tangent square x over 2. So it could be 1 plus tangent square x over 2. Alright. Now I'm going to write this guy and this guy the same denominator by multiply this guy by 1 plus tangent square x over 2. So it turns out to be 1 plus tangent square x over 2. Now the top is going to be 1 minus tangent square x over 2. Now I substitute t for tangent x over 2. So it turns out to be 1 minus t square over 1 plus t square. Alright, so I'm going to box this formula because we're going to use this later. This guy right here. Alright. Integral from 0 to 1. dx right here turns out to be 2 dt over 1 plus t squared. So it could be 2 dt over 1 plus t squared over cosine x is going to be 1 minus t squared over 1 plus t squared plus a. Alright. Now, on the bottom right here, I need to write this guy and this guy the same denominators. So it turns out to be the integral from 0 to 1. 2 dt over 1 plus t squared over a minus 1 altogether t squared plus a plus 1. Alright, over 1 plus t squared. Alright, now I need to simplify this guy and this guy. So I'm going to end up with the integral from 0 to 1. 2 dt over a minus 1 t squared plus a plus 1. Now on the bottom right here, I need to factor a minus 1 out. Alright, so I'm going to have 2 over a minus 1. The integral from 0 to 1 dt over t squared plus a plus 1 over a minus 1. Now we're going to apply the formulas. So it turns out to be 2 over a minus 1 root a plus 1 over a minus 1 arctant t over root a plus 1 over a minus 1 evaluated from 0 to 1. Alright, now substitute 1 over here. We have 2 over a minus 1 root a plus 1 over a minus 1 arctant 1 over root a plus 1 over a minus 1. When you substitute 0 over here, everything should be equals 0. So this is the final answer. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.